Hi all, today's topic is the classification of superconductors, that is type 1 and type 2. Superconductors can be classified into two groups, that is type 1 and type 2. It is done on the basis of the transition from superconducting mode to the normal conductivity mode. We have already discussed in the previous videos that by applying a suitable amount of magnetic field we can reverse the superconductivity mode to the normal conductivity mode. So that transition, there are two types of transition. Depending on that, the materials are classified into two types, that is type 1 or soft superconductors and type 2, that is hard superconductors. In type 1 the transition is very easy and abrupt, that's why they are called soft superconductors. Their superconductivity can be easily taken off. But in the case of type 2 the transition is not easy and it is a gradual process, that is why they are called hard superconductors. They do not give up their superconductivity so easily. That is why they are called hard superconductors. So let us see what is a type 1 superconductor. When a superconductor is placed in an external magnetic field, as the field increases at a particular point known as the critical field, that is a particular value for the external field, at this point the superconductor loses its superconductivity and it will return to the normal conducting mode, and this transition is abrupt and sudden for a type 1 superconductor. Okay, so until the external field reaches the point of Hc, that is the critical field, it will behave like a perfect superconductor. Therefore it will show the property Meissner effect, that is a superconductor will not allow the external field lines to penetrate through it when it is placed in a magnetic field, that is shown in the image. This property of any superconductor is known as the Meissner effect, that is all the field lines will be expelled by the material. This is due to there is an internal magnetization in the material which is acting against this external field, and this is the property of a diamagnetic material. That is why we say until we reach Hc or the critical value of magnetic field, the material will behave like a perfect superconductor. It will have the property of a perfect diamagnet and it will show the property of Meissner effect. Okay, as the point reaches Hc, the field starts penetrating the material. As you can see in the graph, till Hc, the internal magnetization which is acting against it, that is why the vertical axis is having a negative sign, minus mu 0 m. This is acting against the external field and that is increasing proportionally till the point Hc is reached. At Hc, the internal magnetization will vanish, and due to which the field will penetrate the material and it will lose its superconductivity, that is shown in the graph. This kind of sudden transition is known as type 1 superconductors. Now in the case of type 2 superconductors, there are two values for critical fields known as Hc1 and Hc2. There are two critical fields for type 2 superconductors. One is the lower one, that is Hc1, and the upper critical field known as the Hc2. Okay, so till Hc1 the behavior of the superconductor is exactly same as type 1 superconductor, that is the internal magnetization will increase proportionally to the external field and it will be exhibiting Meissner effect and it will act like a perfect diamagnet by expelling all the field lines. At Hc1, what happens? It will lose its property of completely expelling the magnetic field lines. It will be partially penetratable and the field lines start partially penetrating the material. So magnetically it is no more a diamagnetic material, but electrically it is still a superconductor. The superconductive mode is retained even after Hc1 for a certain period of time till the field reaches Hc2. So between Hc1 and Hc2 there is a mixed state or the intermediate stage where the material is in superconducting mode, but magnetically it is no more in a diamagnetic state because the field lines have started to penetrate the material. Okay, after Hc2 what happens? The internal magnetization will completely vanish, due to which the field lines will completely penetrate the material and the superconductivity is destroyed. Okay, so after Hc2 it will behave like a normal conductor. superconductivity is retained till the magnetization of Hc2. Okay, that is the behavior of type 2 superconductor, and this intermediate stage is also called as a vortex state. Okay, now let us tabulate the comparison. In the case of type 1 superconductor, there is only one value for the critical field, while there are two critical fields for type 2 superconductor. And the type 1 superconductor will show Meissner effect and perfect diamagnetism in the entire superconductivity mode. But in the type 2 superconductor, the superconductivity mode lasts till Hc2, but till Hc2 the diamagnetism is not retained. Okay, there is a mixed state in the case of type 2 superconductors, and there is no mixed state in the case of type 1 superconductors. Okay, and the magnetization is lost abruptly in the case of type 1 superconductor, but it is lost gradually in the case of type 2 superconductors. Then the critical field value is very low in the case of type 1 superconductor, that is around 0.1 Tesla, while in the case of type 2 it is around 30 Tesla Hc2. So the practical application is more for type 2 superconductors. Okay, then mostly pure metals are exhibiting type 1 superconductivity, while alloys like niobium, titanium, niobium, tin, those alloys are some examples of type 2 superconductors. Thank you.